Hey, good evening. It's Mr. Estrada here, and our learning target for this video is I can find missing angles in parallel lines cut by a transversal. All right, so as you know, parallel lines are two lines that never intersect. And the way we indicate that in geometry is we'll use this symbol here. You see those little arrows here and here? Those arrows are telling you that these two lines, which I'm going to call L and M, it's telling you lines L and M are parallel. These two red arrows indicate that line L and M are parallel. So we got two parallel lines here. A transversal is a line that intersects two parallel lines at two distinct points. So this is a transversal, this line over here. All right, so now as you can see, the transversal, when it intersects with those parallel lines, it's going to form 1, 2, 3, 4, 5, 6, 7, 8 angles. And let me just go ahead and label those for you. So it's going to form angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So the transversal, when it intersects with two parallel lines, forms 8 angles. And you don't have to necessarily number them this way, but I just wanted you to see that there are actually 8 angles that are formed. And you know, you have your vertical angles like 3 and 2, like 1 and 4, 6 and 7, 5 and 8. You got your vertical angles there. You know, we've been over that before. You got your supplementary angles like 1 and 2, 2 and 4, 3 and 4, and so on and so forth. But in addition to your vertical and your supplementary angles, you also have two types of special angles. And they are your corresponding angles and your alternate interior angles. And in this video, I want to just focus on these two types of angles because they are so important. I would say these are the most important ones in parallel lines cut by a transversal, your corresponding angles and your alternate interior angles. So I want to show you how to identify corresponding angles and alternate interior angles. So let me begin by showing you this. So here you have your parallel lines cut by a transversal. And I numbered the angles. I went ahead and numbered them. Okay, corresponding angles. Now, I want you to take a look at angles 1, 2, 3, and 4. If I was to cut the transversal, say I were to take a scissor and I was to just cut it right here, right through the middle, and then I was to just take the top part like that, and I were to put the top part right on top of the bottom part, you would see that angle 1 falls perfectly right on top of angle 5. That's what I mean by corresponding, right? Corresponding means that if I were to take the top part, whoops, I took the bottom part there, my apologies, let me do that again. If I were to take the top part and put it right on top of the bottom part, where would each of the individual angles land perfectly? Wherever they land perfectly, that's the angle it corresponds to. So you could see that angle 1 is going to correspond to angle 5, right? You could see that angle 2 falls perfectly right on top of angle 6. You would see that angle 3 falls perfectly right on top of angle 7. And angle 4 does the same with angle 8. So those are your 4 pairs of corresponding angles. Let me get rid of my cut line, my scissor line. I don't need that anymore. All right, so corresponding angles, you know, they just correspond with one another. And they are equal to each other. Angle 1 is equal to angle 5, right? As you just saw, it fits perfectly right on top of it, right? You could see that angle 1 is the same as angle 5. Okay, now, alternate interior angles. So your alternate interior angles, So I'm gonna go ahead and identify them for you and see if you could come up with a definition of your own. Angles 3 and 6 are alternate interior, and angles 5 and 4 are also alternate interior. And that's it. You only have two pairs of alternate interior angles. So the alternate interior angles, they are on different sides of the transversal. So you can see, right, angle 3 is on the left side of the transversal and angle 6 is on the right side of the transversal. So they're on different sides of the transversal, but they're both inside the parallel lines. So that's one way to define them. They're on different sides of the transversal, but inside the parallel lines. Okay, let's work out an example. It says here, if the measure of angle 1 equals 75 degrees, find the measure of all the other angles. So angle 1 is 75 degrees. So let me label it 75 degrees. Now, I know that if angle 1 is 75 degrees, angle 4 automatically has to be 75 degrees because these are vertical angles. So I know that has to be 75 degrees. I also know that angle 1 and angle 2 are supplementary. So I know that angle 2 has to be 180 subtract 75, and that's going to be 105. And I know angle 3 has to also be 105 because these are vertical angles. All right? Now, how do we figure out the rest? Well, let's think. Let's think for a little bit, right? Remember that thing I did where I took the top part and I put it right on top of the bottom part? Angle 1 corresponds to angle 5, right? So that means whatever angle 1 is, angle 5 will be the same. So angle 1 is 75 degrees. Angle 5 should also be 75 degrees. These angles are corresponding. Angle 2 was 105. Angle 2 corresponds to angle 6. If I was to take the top part and put it right on top of the bottom part, angle 2 falls perfectly right on top of the 6. So if angle 2 is 105, angle 6 has to be equal to it. It has to be the same. And then we could use the definition of vertical angles to get the rest. If angle 6 is 105, angle 7 should also be 105. And angle 8 is the same as angle 5, so it should be 75 degrees. And that's how you find the angles. All right, I hope this video helps. Take care.